Hello everyone, today we're going to look at basic definitions of complex numbers. So we start with what's called an imaginary number. Usually we denote it by I for imaginary, but our book is going to use J. In some other situations they do use J instead. If I accidentally say I, it's because I'm used to using I, but again it is going to be J for the purposes of our book. So J is going to be the square root of -1. This is called the imaginary unit. What we're going to do is we're going to use properties of radicals to express and simplify square roots of other negative numbers, so not just -1. So something like the square root of -9. What we're going to do is we're going to split it up into root -1 and root 9, and I can do this because 9 is positive. If both of my numbers were negative, so if I was, let's undo that. If I was looking at the square root of -9 times -1, I would not be able to split that up into these two. Okay, at least one of my numbers has to be positive. So since 9 up here is positive, I can split it up. And then square root of -1 is J, square root of 9 is 3, and then just like with variables or any other types of units, we put the J at the end. So we don't say J3, we say 3J, just like we would with 3X or 3A. Okay. So root -9 is 3J. So let's look at the square root of -5. We'll split that up into root -1 and root 5. And again, I can do that because 5 is positive. Root -1 is J, root 5 is root 5. I can't go any further than that. And again, if the coefficient of J were an integer, then we put the J last. But if there's a square root, the square root always goes last. And that's because we don't want something like this, where I can't tell if J is inside the square root or not. Okay, so remember, square roots always come at the end. Square root of -20. I'll split it up between -1 and +20. So root -1 is J. So I still have root 20. I can simplify that further. Right, 20 is 4 times 5, and I know the square root of 4. And again, I'll put the 2 first, then the J, then the square root of 5. Okay, and that's always the order that you'll see it in. Non-radical coefficient first, then the J, then the radical. Square root of -9 times -8. So again, I can't split that up because they're both negative. So I always want to go back to rules of order of operations, PEMDAS. Right, there's an invisible set of parentheses right there. So I want to simplify what's inside the radical first. I know what -9 times -8 is. It's 72. So I do that first, and then I notice I don't have a negative, so this is actually a real valued number, and I'll continue simplifying it like we did in previous courses. So 72 is 36 times 2. Square root of 36 is 6, so we have 6 times the square root of 2. How about the square root of 9 times the square root of -8? So they're already in separate square roots here, so it's a very different problem than C. So I'm going to take out each square root of -1, and that each of those are going to come out as a J. So I have a J times root 9 for my -9, a J root 8 for my root -8. So I will square the J, and then I'm going to put my 9 and 8 together to make 72 inside the square root, which we already learned is 6 root 2. So I'll have 6J squared root 2. So the question is, what's J squared? So I'm going to look at powers of J in general. So anything to the 0 is 1. Anything to the 1 is itself. And now we come to j squared. So j squared is root negative 1 squared. And the square and the square root cancel, and we're left with negative 1. So j squared is the real number, negative 1. And that's going to be really, really important. We're going to use this a lot in the coming section. So we need to remember that j squared is negative 1. What about j cubed? So j cubed I can rewrite using rules of exponents as j squared times j. J squared is negative 1, and then j is j. So j cubed is negative j. What about j to the 4th? I can rewrite that as j squared times j squared, again just using rules of exponents. Each of those j squareds is negative 1, so I have negative 1 times negative 1, which is 1, which if we go back is j to the 0. So these are going to come in a cyclic pattern. And they just keep repeating. I'm going to have 1, j, negative 1, negative j, then back to 1, j, negative 1, negative j, then back to 1, j, negative 1, negative j. So no matter what power of j I have, I will be able to simplify it to one of j, negative j, 1, or negative 1. So in your homework or in anything, you should never see a higher power of j than 1 because we can always simplify it. So the question is, how do I simplify something like j to the 20th, j to the 301st? So these cyclic patterns are in 4s, right? We got j, negative j, 1, negative 1. We have 4 values there. So every 4, it repeats. So what I want to do is I want to look at what the remainder is when I take my exponent and divide it by 4. So I mean remainder. I mean, let's go back to like 3rd grade math, right? And you look at, okay, let's divide 2 into 31. What's the remainder? Okay, I don't care what 20 divided by 4 is. I want the remainder. What part of that doesn't go into the 4? So for instance, let's do j to the 21st. When I divide 4 into 21, I have a remainder of 1, right? 4 goes into 20 exactly, so I have that extra 1 left over, and that's my remainder. So j to the 21st is j to the 1st, which is j. How about j to the 302nd? When I take 302 and divide it by 4, what's the remainder? The remainder is 2. 4 goes into 300 exactly, and I have 2 left over. If you're not good with division in your head, then you can shove this into your calculator, and you just have to convert that fraction into a remainder. So when you divide something by 4, you either get 0.0, 0.25, 0.5, or 0.75, right? You'll never have anything other than one of those things. So if it's 0.0, then that means it divided evenly, and your remainder is 0. 0.25 is 1 over 4. That 1 is the remainder. 0.5 is 1/2, which is 2 over 4. So that's the remainder of 2. And 0.75 is 3 over 4. So that's the remainder of 3. Okay, so you can use your calculator for this, but hopefully figuring out the remainder when you divide by 4 isn't too bad. But it's either 0, 1, 2, or 3, and that corresponds to j to the 0, j to the 1, j to the 2, and then j to the 3. Right, so we have those, again, those 4 possibilities. So for 302, the remainder is 2. So j to the 302 is j squared, which is negative 1. J to the 39. The remainder of 39 divided by 4 is 3. Right. Something good to remind yourself of is if I have an even number and I'm dividing it by 4, the remainder is either 0, because it divided evenly, or 2, because there's 2 left over. If it's an odd number and I'm dividing it by 4, it's not going to divide evenly, and I'm either going to have a remainder of 1 or 3. So if it's even, I know that the answer is a real number. It's either 1 because the remainder was 0, or it's negative 1 because the remainder was 2. If I have an odd number, then the answer is an imaginary number. It's either j because the remainder was 1, or the remainder is 3, which gives us j cubed, which is negative j. So j to an even power is a real number. It's either 1 or negative 1. J to an odd power is imaginary. It's either j or negative j. So that's just something to keep in mind to make sure you're doing it correctly. Okay, so now we're going to look at what's called complex numbers. So the rectangular form of a complex number is a plus bj. A and b are both real numbers. Okay, so a and b are both real numbers, and then I'm taking that real number b, multiplying it by j, so that b times j is an imaginary number, but b itself is the coefficient of j, is a real number. A is called the real part, and b is called the imaginary part. So again, the imaginary part is b is a real number. But when I multiply it by j, excuse me, I get an imaginary number. But the imaginary part is b, the coefficient of j, which is a real number. I cannot stress this enough. The imaginary part is a real number. It's the coefficient of j. Two complex numbers are equal if their real parts are equal and their imaginary parts are equal. So what we're going to do is we're going to have two complex numbers equal to each other, and we're going to solve for, say, x and y. So if x plus 3j equals 5 minus yj, what are x and what are y? So again, their two complex numbers are equal if their real parts are equal and their imaginary parts are equal. So what we're going to do is we're going to set up a system of equations. So we dealt with systems of equations in Tech 1. So we're going to see it come up again. So the real parts, on the left, the real part is x. On the right, the real part is 5. So I'm going to set them equal to each other, so x equals 5. For the imaginary parts, the imaginary number is 3j. The imaginary part is, again, the coefficient of j, which is just 3. On the right, the imaginary part is, again, the coefficient of j, which is negative y. So for the imaginary parts, we have 3 equals negative y. These equations are fairly easy to solve, right? I don't need to do anything fancy here. X equals 5 and y equals negative 3. Usually they'll be a little bit harder than that, so let's try x plus 4 minus 3yj equals 3y plus xj minus 2j. So then we're going to set up the reals equals the reals, the imaginaries equal the imaginaries. Excuse me. So for the real part, on the left-hand side, everything that doesn't have a j is the real part, so it's x plus 4. On the right, the part that doesn't have a j is 3y. So x plus 4 will be 3y, and that's the real part. For the imaginary part, again, I want the coefficients of j. So on the left, the coefficient of j is negative 3y. On the right, I have two things that have j. I have a plus x and a minus 2. So x minus 2 will be the imaginary part on the right. I could rewrite this by pulling out the j, and I would have my x minus 2. So this would be my b, would be my imaginary part. So negative 3y equals x minus 2. So this is a little bit more complicated than the last one, but again, we did learn how to solve systems of equations back in Tech 1. So I'm going to use the substitution method. So my first equation, I'm going to solve it for x. So x equals 3y minus 4. Then I'm going to plug that into my second equation. So we have our negative 3y equals x, which is 3y minus 4, minus the 2, right? So I'm substituting in my x equals 3y minus 4 into the second equation. And then we're going to clean that up. We're going to put all of our y's on one side, put our constants together, so that will give me negative 6y equals negative 6. So y is 1. Then I'm going to plug that into the equation that I used in my step 1. So x equals 3 times 1 minus 4, which is negative 1. With all solving of equations, you should check your answer. So if I plug in my x and my y into here, do I get out the same thing? So is negative 1 plus 4 minus 3 times 1j, is that equal to 3 times 1 minus j minus 2j? Both sides equal 3 minus 3j, so I'm good to go. So let's try another one. 3y minus 4xj equals 3x plus 2 minus yj plus j. So again, we're going to set up our reals. So on the left, everything that doesn't have a j is 3y. On the right, everything that doesn't have a j is 3x plus 2. For the imaginary part on the left, my coefficient of j is minus 4x. Again, on the right, I can factor out a j, and I'm left with negative y plus 1. So this is my imaginary part on the right. All of the coefficients of j. So what I'm going to do is I'm going to take the second equation and solve it for y. So y equals 1 plus 4x. Then I'm going to substitute this into my first equation. So 3 times y, but y is 1 plus 4x, equals 3x plus 2. I'm going to clean that up. Right, I'll write out the steps here. So 3 plus 12x equals 3x plus 2. So I will bring my 3x over by subtracting it. I'll subtract my 3 to the other side. So I'll have 9x equals negative 1, which is how I get x equals negative 1 over 9. I'm going to plug that in, excuse me, for x in my y equals 1 plus 4x. Simplify it, and y is 5/9. So again, we're going to check it. If we plug in, excuse me, we plug in x equals negative 1/9 and y equals 5/9. Both sides should give us 5/3 plus 4/9 j. Okay, so always check your answers. It's really important to make sure that you do that. So let's do some more examples of fully simplifying. So the square root of negative 4j squared. What I want to do here is simplify what's inside the square root, so negative 4j squared. J squared is negative 1. So we'll have negative 4 times negative 1. That's just 4. So we end up with the square root of 4, which is 2. How about negative root 1 plus root negative 1? So where those negatives are very, very important. Root 1 is just 1. Root negative 1 is j. So I have negative 1 plus j. How about j to the 9th times root 8? We'll start with the j to the 9th. When I take 9 and divide it by 4, I have a remainder of 1 because 4 goes into 8 evenly, so there's 1 left over. So j to the 9th is j to the first, which is just j. So that gives us j times the square root of 8, but 8 is 4 times 2, and I know what the square root of 4 is. So root 8 becomes 2 root 2. So j root 8 is 2j root 2. So again, the coefficient, then j, then the radical. How about j cubed times root 50 times root negative 50? So what I'm going to do is I'm going to split up this guy into root negative 1 times root 50. Root negative 1 is j. So I'm going to have j cubed times j, which is j to the 4th, and then our 2 root 50s. So that's my first thing I'm going to do. Get rid of that j in there and add it to my j cubed, or multiply it rather to my j cubed. J to the 4th is 1. Root 50 times root 50 is just 50. So 1 times 50 gives me 50. Okay, so this fairly complicated looking thing is just 50. How about root negative 48 plus 3j to the 10th? I'm going to deal with the j's and the root negative ones first. So again, this root negative 48 is root negative 1, root 48. Root negative 1 is j. So I'll start with j times root 48 for my first part. For the second part, we have j to the 10th. When I take 10 and divide it by 4, I'll have a remainder of 2, because again, 4 goes into 8 evenly, and then there's 2 left over. So 3j to the 10th is 3j squared, but again, j squared is negative 1. So 3j squared is just negative 3. So we have j root 48 minus 3. I want to simplify root 48, so 48 has a factor of 16, so I'm going to pull that out. So we have j root 16 root 3 minus 3, and then we know what the square root of 16 is. So negative 3 plus 4j root 3. You always want to put it in rectangular form, which again is a plus bj. So we always want the real part first and the imaginary part second. We'll see why that's important when we start translating it into what's called polar form. All right, so again, a plus bj is rectangular form. Real plus imaginary. Okay, so that's why you change the order. And then how about 3j cubed times root negative 12 plus 4j to the 23rd times root negative 36j squared. So we have a lot going on here. The first thing I'm going to deal with are those negatives inside of our radicals. So root negative 12 is going to be negative 1, root negative 1, root 12. So again, root negative 1 is a j. I'm going to combine that with that j cubed, and that's going to give us 3j to the 4th times the square root of 12. And then inside here, again, we have negative 36j squared. J squared is negative 1. So we have negative 36 times negative 1, which is positive 36. Okay, so I'm going to just do those two parts first. And that will give us 3, again, j to the 4th, root positive 12, plus 4j to the 23rd, root positive 36. Next, we're going to clean it up a little bit further. J to the 4th is just 1. Right, 4 goes into 4 evenly, so the remainder is 0. J to the 0 is 1. J to the 23, when I take 23 and divide it by 4, I have a remainder of 3, because 4 goes into 20 evenly, so there's 3 left over. And j cubed, remember, is negative j. I'm also going to do this square root really quickly, because I know the square root of 36 is 6. So that will give me my 3, and again, j to the 4th is 1, root 12. And then my j to the 23rd is a negative j, so minus 4j, root 36 is 6. And next, I'm going to look at the square root of 12. 12 is 4 times 3. So I'm going to split that up. I'm also going to simplify 4j times 6. That's just 24j. And then lastly, I know what the square root of 4 is. It's 2, and then 3 times 2 will give me 6. So I have 6 root 3 minus 24j when it is all fully simplified. So some of it takes a little bit of work. You got to do a couple steps, a couple different steps, right? You want to look at the negatives inside the square roots. You got to look at the powers of j. You've got to look at simplifying the radicals themselves also. The last thing that we're going to look at is something called a complex conjugate. If it's already, you already know that you're referring to complex numbers, and sometimes it's just called the conjugate. So the conjugate of a plus bj is a minus bj. So we have the real part stays the same, the imaginary part changes signs. So we go from a positive b times j to a negative b times j. So let's find the conjugate of the following values. 3 plus 4j. So again, the real part, the 3, is going to stay the same. The imaginary part, 4, is going to change signs. So 3 minus 4j. Negative 2 plus 6j. The real part, negative 2, stays the same. The imaginary part, 6, changes signs. So negative 2 minus 6j. 5j minus 8. So notice this is not written in rectangular form. The imaginary part is written first. So you want to make sure that you're not just changing the sign of the second part, but that you're changing the sign of the imaginary part. So the imaginary part, 5, is going to get changed to negative 5. The real part, negative 8, stays negative 8. Always put your answer in rectangular form. So I'm going to rearrange it and put it as negative 8 minus 5j. 2. So it is a real number. So if I want to put it as a truly complex number, I can always write plus 0j. And then when I change the sign of the imaginary part, it would be 2 minus 0j. But that's not doing anything. It's still just 2. So the complex conjugate of a real number is itself. If I have just an imaginary number like 8j, I could rewrite it as 0 plus 8j. And then the 0, the real part, doesn't change. I change the imaginary part. I'd have 0 minus 8j, but again, I don't need that 0. So the complex conjugate of a strictly imaginary number is the negative of it. How about 5 minus 4j? So in the real part, the 5 stays the same. The imaginary part, negative 4, changes sign, so it goes from a negative 4 to a positive 4. So 5 plus 4j. And then lastly, negative 3 minus 5j. So again, the negative 3, the real part, stays the same. The imaginary part, negative 5, changes sign. And we have negative 3 plus 5j. Okay, so again, always make sure your answers are in rectangular form, but simplify. You know, I don't want a 0 in there. 2 is in rectangular form. Negative 8j is in rectangular form. Okay, all of my answers are in rectangular form. The only time it's not is if you have something like this, where you have the imaginary part first and then the real part. Okay, that one is not in rectangular form, but all the rest are. Okay, so make sure that you read through the book and let me know if you have any questions. Thanks.